All right, we're gonna start off with simple ones, all right, and then we are going to build up, okay?
Mhm.
It says no calculators here, but don't worry about this just yet. So let's do one by one. -3 to the power of 4. What's the idea behind this one? What do you think? Is the answer gonna be a positive or a negative for A?
Um,
So this is the trick, okay? You look at the exponent. If it's an even exponent, okay, then what does that mean? That means something like this, right? -3 times -3 times -3 times -3.
so positive.
Yeah, it's going to be positive. So we can just kind of cancel out. We can ignore the signs here. What's 3 times 3? That's a 9. And 3 times 3 is also a 9. What's 9 times 9?
81.
81. And that'll be the final answer there. Okay.
Mhm.
Look at B. Now, B, you have to be careful. So the power 4 only applies to the number. It does not apply to the sign, okay? So we're not multiplying the negative sign 4 times. What do you think the answer is? We know 3 to the power of 4 is 81 from part A. So for B, is the answer positive 81 or negative 81?
Positive.
So in this one, in B, this is what it means. Okay, you have a negative sign and then you're multiplying 3 4 times like that, you see? Compared to A,
Mhm.
where we were multiplying the negative sign 4 times. In B, there's only one negative sign. The power 4 does not apply to the negative sign because it's not in a bracket,
Okay.
which means the final answer is going to be negative 81.
Mhm.
How would we do this? It's not that hard, okay? Let's do this one by one. What's -2 cubed? Is it positive number or negative number? This guy.
Um, Positive.
It's only gonna be positive if the exponents are even, all right? Cool.
Mhm.
So again, this one, positive or negative?
Negative.
Negative, right? Do you get that? Like, look at this. -2 to the power of 2 means you're multiplying negative sign an even number of times, right?
Mhm.
That should mean it's a positive number. But if you have an odd exponent like we do here, we're multiplying the negative sign thrice or an odd number of times. That means, see, this one and this one will make a positive, but you still have this one. Same idea applies. Doesn't matter how big the number is. -2 to the power of 101. It's going to be a negative result because we're multiplying the negative sign an odd number of times. But if you have -2 to the power of, I don't know, like 100,000 or 100,000,008, is this going to be a positive result or a negative result?
Um,
Is this an odd number or an even number? That's all that matters. It's an even number, yeah?
so it'll be positive.
That would be a positive result, that's right. We know 2 cubed is 8, or you can just do it in your head, right? 2 times 2 is 4, times 2 is 8. So -2 cubed, cubed just means power 3. It's going to be -8, okay?
Mhm.
And then we have 1/8 whole squared. This means it's 1 squared 1, and then 8 squared 64, like that. So this is going to reduce to -8/64. So when you have multiple fractions that are being multiplied, you multiply the numerator with the numerator. And if there's no denominator, you can assume the denominator is a 1, okay? And then you multiply the denominator with the denominator. What does this reduce to? -8/64.
Um, 8/8.
-1/8.
Oh.
because 8 goes into 64 8 times, right? 8 squared is 64.
Mhm.
So that's the answer for that one. Okay, is that good so far?
Mhm.
I'm going to give this to you. 2 power 5 is 32. Okay, we're going to use this as a reference. 2 power 5 is 32. You can always plug it in a calculator as well. Tell me the answer to D, is that going to be positive 32 or negative 32?
Negative.
Yeah, good. Negative 32. What about E? Positive 32 or negative 32?
Also negative.
Yeah, good. Perfect. There we go. So they're trying to trick us here, but it's not going to work. Now this one, you don't actually have to open it. You could always open it, but you don't have to. In this case, let's just do it. Negative 6 squared, positive 36 or negative 36?
Positive.
Yeah. What's 1 over 6 whole squared?
Um, 1/36.
Yeah, good. 1 over 36. What does this reduce to? It's just 36 times 1 over 36. So look at this. 2 times 1 over 2. The 2's cancel out. You're just left with a 1, okay? If you have A times 1 over A, the A cancels out. You're just left with a 1. Doesn't matter. If you have A cubed B squared times 1 over A cubed B squared, these two cancel out. You're just left with a 1. So it's 36 times 1 over 36.
1.
Yeah. Do you understand that?
Mhm.
And I'll show you steps. It works like this, right? If there's no denominator, just add an invisible 1 there. Then you multiply 36 with 1, numerator with the numerator, and you multiply the denominator with the denominator. So you get 36 over 36, which is a 1, right?
Mhm.
Good so far?
Yep.
It's not that bad, honestly. It's usually it's just a two-step answer. It's gonna be a two-step answer. Look at this. We've done this before. What's 2 over 5 to the power of 0?
1.
1, exactly. And what is 3 to the power of negative 1? Do not say negative 3, okay? It's not negative 3. What's 3 to the power of negative 1?
Um,
So exponent is negative. Let's make it positive.
do you put it under 1?
Yeah, you put under a 1, okay? So that just becomes 1 over 3 to the power of 1. Now what's the final answer here? 1 times 1 over 3.
1/3.
Yeah, and you're done. See? It's a
Mhm.
two-step answer. You don't even need a calculator, nothing. Okay, let's do this. What's 5 to the power of 0? Let's say 1, right?
1.
What's 3 to the power of negative 2?
Positive 6.
Wrong. Common mistake.
You.
It's not nothing to do with 6.
Oh, 9.
Yeah, it's gonna be not well, what would it be? It's gonna be 1 over 9, okay?
Mhm.
And 1 over 9 over 1, what's that? It's just 1 over 9.
Mhm.
Anything you multiply at 1 or you divide 1, you can just ignore that. You just get whatever you have left, okay? See that?
Mhm.
Okay, so here's another thing, right? What's 1 over 3 to the minus 2? And again, it has absolutely nothing to do with 6.
1/9.
It's going to be exactly 9, not 1 over 9, and I'll show you why. Step 1, we're going to toss this in the denominator to make it positive, right? Like that.
Mhm.
Step 2, we're going to open that bracket. What's 1 over 3 squared?
1/9.
Yeah, 1/9. And now look at this. We have 1 divided by 1/9. That's the same thing as, again, whenever you have a division sign, you want to turn it into a multiplication and flippity flip. And the answer is exactly 9, okay?
Mhm.
Another way to do this, you can just do it like this. You can distribute this. 1 to the power of anything is a 1. Like 1 to the power -1,000,000, 1 to the power +10, anything, 0. 1 to the power of anything is a 1, okay?
Uh-huh.
So what does this mean? This means you have 1 to the power -2 over 3 to the power -2, which established 1 to the power of anything is a 1. And you see 3 to the power -2 is in the denominator. We can bring it up top. And when you change its dimension up or down, you got to change the sign. It becomes +2. And 1 times 9 is 9. You see that?
Mhm.
Okay, this one. What do we do? First step, we have a negative exponent.
You put it under 1.
All right, good. So what's 2/5 squared?
4/25.
Yeah. So you have 1/4/25, like that, right?
Mhm.
Which means the same thing as 1 divided by 4/25. And we can do a quick flip here. 25/4. So the final answer is simply 25/4. Does that make sense?
Mhm.
Here's an advanced strat. It's not advanced, it's just a new rule that will help you solve these kinds of problems. And again, this is for efficiency purposes, okay? The answer is gonna be the same, but this is way quicker. If you have anything in this form, a over b to the power of -c, okay, like we do here, what you can do is you can flip the fraction to begin with, and the exponent becomes a positive. Okay,
Mhm.
we're basically just doing what we did here, but we're simplifying it into 2 steps. So in this case, we can just flip this upside down. We have a negative exponent, and only do this when the exponent is negative. We can put the denominator on the numerator, we can put the numerator on the denominator, and we can make that a +2. You see that?
Uh-huh.
And then open that, you get 25/4 in 2 steps, instead of how many more we did here. It's not
Okay.
really advanced, it's just like, this is what we will end up doing to save time. Okay, these are just simple exponent laws. 5 to the 2 times 5. How many 5s?
3.
Yeah. What about k? How many 5s?
14.
Nope, try again, not 14. 14 would be if it was like this, you would get 14, which it's not. This would be up, and then you get 5, 8 times 5, 6, that would be 5, 14, which is not the case here. You simply add them
Is
up,
it
right?
2?
Yeah, it's just 2, you simply add them up. What about L?
Um,
It's not 14 there either.
is it also 2?
It's not 2, try again. Just add the exponents.
-2.
-2, yeah. And then we can toss this in the denominator, like that. Okay,
Mhm.
and then there'll be 25. 1/25, 5 squared is 25. 5 cubed is 125. Let's look at these ones. So when you have a double exponent, like an exponent with an exponent, you multiply them, okay? Like in the last question, we added them, but in this case, you would have to multiply them for m. What do we get?
2 to the power of 6.
Easy, right? What about n?
Um, 10 to the power of 3.
Yeah. Oh,
10 to the power of 4.
yeah, good. There we go. There we go. We're getting a hold of this. Are these ones? So those are the exponent laws, right? The next thing we'll be doing is simplifying, and these guys are called radicals. Radical just means there's like some root there. Okay, these two are square roots, but it could be any root. Those are called radical forms. So how do we simplify something like this? This is how you do it. And by the way, this means the same thing as 12 to the power of 1 over 2. If you plug this in a calculator, you get some gibberish. So that's not simplification. We can't do that because 12 is not a perfect square. You know, perfect square like 4, 9, 16, 25. These guys are called perfect squares, yeah?
Mm-hmm.
64, 81, yada, yada, 72. Not 72, 64, 81. And then you have some perfect cubes as well, like 8 is 2 cubed, 27 is 3 cubed, 64 is 4 cubed, 125, 5 cubed, yada, yada. But these guys are not perfect. So how do we simplify them? And this is the idea, okay? This is the idea. Because there's a square root outside, right?
Mm-hmm.
We are going to write these in terms of a perfect square times something. Now, what does that even mean? Here, look at this. Maybe we have square root of 32, okay?
Mm-hmm.
Square root of 36. So how do you simplify this? I know 32, I look at these guys. 32 is, which one fits the bill? 16 fits the bill. 32 is 16 times 2, yeah?
Mm-hmm.
Which is and now we can break apart the radicals. That's the square root of 16 times the square root of 2. And square root of 16 is 4, so the answer is 4 root 2, final answer. See that? So you're gonna write that question as in terms of a perfect square times some number. Now tell me, in terms of a perfect square are these numbers. How can we rewrite 12? It'll be the square root of some perfect square times some number. And these are your perfect square numbers.
4 times 3.
Yeah, exactly, 4 times 3. And that's the same thing as square root of 4 times square root of 3, yeah?
Mm-hmm.
Square root of 3 is gonna be some gibberish number, 4 is 2, so 2 root 3, there we go. It's not gibberish. By gibberish, I mean like irrational number. Okay, square root of 2 is also an irrational number. That kind of like never stops. Okay, that never stops. Not necessarily never stops. In fact, the definition of an irrational number is a number that you can't write in terms of a fraction. Okay, like
Mm-hmm.
1.333 is also a number that never stops, right? Or 1.33 recurring. It's a number that never stops. So, but this one, we can write this as a fraction. How do we write 1.33 as a fraction? If you want a hint, I'll give you this. 0.33 is 1/3.
4 over 3.
Yeah, exactly, 4 over 3. So this, even though it never stops, this is not an irrational number, okay?
Mm-hmm.
This one is root 3. There's no way you can write that in terms of something over something. Root 2 as well, there's no way you can write that. Those are irrational numbers. And that's what we'll end up with most of the times when we simplify radicals. Look at B. We want to write 18 in terms of a perfect square times some number.
9 times 2.
Yeah, see how easy this is? And that's just going to be 3 root 2. Because square root of 9 is 3.
Okay.
Now this is where things get a little bit tricky. So in the previous question, we had a square root. That's why we're looking at perfect square numbers, right?
Mhm.
Now we have a fifth root, so we got to look at perfect fifth numbers, fifth square. This one we can just do it like this, okay? Let me give you a cheat sheet here. 2 power 5 is 32. Okay, we're going to use these. 2 power 5 is 32. And this is our perfect fifth square number. 3 power 5 is 243. Okay, let me just do 4 power 5. And 4 power 5, again, why am I doing power 5? Because there's a fifth root here. And that is 1024. Cool.
Mhm.
Now look at this. What's the fifth power of 243? Or the fifth root of 243? Look at this number. It's simply a 3, okay?
Mhm.
Like how 3 cubed is 27, right? What's the cube root of 27?
3.
Yeah, exactly. Same idea here, right? Like 2 power 5 is 32. What's the fifth root of 32?
2.
2. Well, what if I spice it up? Look at this. What's the fifth root of 64 now? Calculator will probably not help you here. Yeah, it gives you some gibberish. This is how you do this question, okay? So you remember in the previous question, we wrote it in terms of a perfect square. Now we're gonna write this in terms of a perfect fifth power number. Look at this, this is our list, right? 32 to 43. 64, we can write this as 32 times 2, okay?
Mhm.
What's the fifth root of 32?
2.
2. What are we left with? Fifth power of 2, and there we go, that's the answer.
Oh, okay.
486, it's not a perfect fifth number, fifth power number, but we can write this in terms of 243 times something, right? This is the same thing as 243 times 2. Yeah.
Mhm.
And we know the fifth root of this is simply a 3, and then we're left with fifth root of 2, and there you go, that's the final answer. You see that?
Mhm.
So if there's a square root, we're going to look at perfect square numbers. If there's a higher power root, then we look at perfect cubic numbers and stuff like that. So here, 27 over 16, we can't reduce that. So we have to write both of them in terms of a perfect square number times something. Actually, the denominator, we can kind of straight up cancel that, can't we? Look at this. This means the same thing as square root of 27 over the square root of 16. We know the square root of 16 is a 4. Yeah.
Mhm.
To simplify the square root of 27, you're going to have to write that in terms of a perfect square number, something times something. Tell me 27.
9 times 3.
Yeah, exactly. 9 times 3. And then we know the square root of 9 is just going to be 3. Then you're left with another 3 in the radical and then over 4. And that's the final answer. Okay.
Mhm.
This one, 36, we know that's 6. 18, we know we can write that as 9 times 2. So you get 3 root 2 over 6. What does this reduce to?
Um,
What does 3 over 6 reduce to?
1 over 2.
Yes, that's right. So you get root 2 over 2, okay? Because it
Mhm.
goes into itself once, goes into 6 twice. Root 2 over 2.
Okay.
Now, for I, we have a cubic root, yeah? A third root. So we got to look at perfect cubic numbers. 2 cubed 8, 3 cubed 27, 4 cubed 64, yada yada, okay? So tell me, how do we simplify the cube root of 81? Because that's not a perfect cube number, yeah? We're gonna have to write in terms of this times something.
Um,
It's going to be 27 times 3, okay?
mhm.
What's the cube root of 27? It's here.
3.
Yeah, it's 3, right? So look at this. You get 5 times, and the cube root of 27, we get a 3 on the outside, okay?
Mhm.
Because that's the cube root of 27. And then we are left with the cube root of 3. And these two are perfect like numbers. We can just multiply them. 5 times 3 is a 15. And there we go. Final answer.
Okay.
Okay, having fun?
Maybe.
Wrong answer. The only answer is yes. The only right answer is yes. All right, let's look at this. Again, cubic root of 500, okay? And I'm gonna
Mhm.
give them to you again. So 2 cubed is 8, it's too small. 3 cubed is 27. 5 cubed is 125. How do we simplify m?
Um,
It's gonna be one of these numbers times something. One of these guys. It'll be the 125. 125
times 4.
times 4, right? And we know the cube root of 125 is a 5. And what are you left with? So cube root of 125 is a 5. There's something else in here. Wouldn't use up the cube root of 4, right? And there you go. That's the final answer. 5 times the cube root of 4.
Mhm.
Does that make sense to you?
Yes.
All right. So for n, you're going to have to think outside the box. Because now we have the 4th root, right? But if you look at the numbers, 2 power 4 is 16. Even the smallest 4th root, you can't write 24 nor 14 in terms of 16. Okay. So what do we do in this case? We're just going to combine them into one big 4th root like this.
Mhm.
And that is going to be, what's 24 times 14? 336. Okay.
Uh-huh.
4 power 4, maybe we're going to need it, is 256. It's too big. This is too big. Now the question is, how do you write 336 in terms of either this times something or this times something? 336 is not divisible by 81, but it is divisible by 16, okay? Look at this. We get,
21 times.
yeah, exactly. You got 16 times 21. Now what'll be the final answer here? Like we did here, we're on this step. How do you go from here to here? Same idea.
Um,
What's the 4th root of 16?
2.
What else is left?
The
And
21.
yeah, the 4th root of 21. And there we go. That's the final answer, okay?
Okay.
And we leave it in this form because this number is irrational. It keeps going on forever.
Mhm.
Look at O. How do we do O? No, that's just a square root question. these are our perfect. And again, if you have the same root, like here, fourth root, we just combine them. You can just combine them in this case. You can just do like 63 over 7. What's 63 over 7?
9.
9. What's the square root of 9?
3.
And there we go, easy as that. Okay.
Mhm.
It says simplify and eliminate. Answer has to be in a positive exponent in terms of a positive exponent. All of them are one-step answers. x5 times x8.
X to the power of 13.
That's right, x13. B.
2x to the power of 6.
No.
Why?
There's an x6 there. Remember that if there's a bracket, the exponent applies to every element inside the bracket.
Oh,
So what should it
so
have been?
4.
4, exactly. That's why. Okay, 4x6.
Okay.
C.
Um, X to the power of 2.
Yeah, that's right. X to the power of 2. Easier than squeezing lemons. Let's try this one.
Lemons really aren't easy to squeeze sometimes.
Yeah, that's true. They're not. You need some grip strength, I guess. What about this?
Um, 9x to the power of 3.
Not 9. Try again. We're not, remember this, we're not doing 3
Oh,
times 3. We're doing 3 to the power of 3, which is not 9.
so 27.
Yeah, 27x3 there. These are very simple, right? Look at this. D would be y15. F would be y4. Yeah, it's a one-step answer. What about G and H? Now there's some negative exponents here. What would it be for G?
To the power of -5.
Yeah, but we don't want negative exponents, so what do?
You put it under a 1.
Yeah, you put it under 1. Okay, H.
Um, one over x to the power of 4.
Yeah, that's right. Good job. One step, right? All these are one steps. I, that'll just be x5. Do you agree?
Mm-hmm.
Let's do some difficult ones because now it's getting a little bit too easy. Here, let's try O. Alrighty, how do we do this? I'll give you a hint. Leave the first guy as it is. Don't touch this one. Let's do this one. We see the cube. Just remember, it applies to everything inside the bracket, okay?
Mm-hmm.
So you get x cubed over 3 cubed, like that. Now what?
Uh-huh. Um, Do you add the exponents?
For the x's, yeah, you do, because you're multiplying them. So you'll get x7, but what about the 3's? Now this has a power of 1, right? So do you want to bring the 3 cubed up, or do you want to bring the 3 power 1 down?
Bring the 3 cube up?
Okay, you could do that, but it's easier to bring the power 1 down, because then you automatically get a positive exponent, you see? You're doing 3, 1 over 3, 3. If you bring the 3, 3 up, you're gonna get 3, negative 2. So you're gonna have to use one extra step. Whereas if you just bring this down, it becomes a subtraction, right?
Uh-huh.
Maybe that part is confusing you. This one's gonna be 3 squared, okay? Look at this, 5 squared over 5, 5. Doesn't matter which one you move, their signs will flip, okay? If I bring this up, it's gonna be 5 squared times 5 to the negative 5. Now you're multiplying them, so you add them, 5 to the negative 3. And then you can toss it in the denominator like that to make it positive. Same idea here, okay? Even if you bring the up guy down, if you bring this down, okay, the sign still flips. You're gonna get 1 over 5, 5 times 5, negative 2. The positive 2 became negative 2, and then because they're being multiplied here, you just add them up. See, same answer. So it really doesn't matter which one you take up or down, but if you want to save a step, you want to bring, you want to change the one that's lower. Like you want to bring the 2 down, okay? So you end up with a positive exponent automatically, which will save you a step. All right, let's look at these guys. Let's start with P. Again, that's a one-step answer, but you have to be careful. You can use multiple steps if you want. Let's do that. What do we get in the numerator?
Y to the power of 8?
Yeah, what about the denom?
Y to the power of negative 1?
Yeah, that's right. So now do we bring the negative 1 up, or do we bring the 8 down?
You bring the negative 1 up?
Right, so do we get 7 or 9?
9?
Yeah, good. Done. What about Q? What would be the first step?
You multiply the exponents?
Right? So what do we get?
To the power of 27?
Interesting. No, it's not going to be here. Let's just simplify the bracket first, okay? The negative 2, we'll just leave it as it is. B3 times B3, what is that?
B6?
Yeah, now open the brackets. The 3 on the outside applies to negative 2 and also applies to the B. So what's the final answer here? It won't be B27, that's for sure.
Negative 6B?
Nope. Negative 6B is just negative 6B?
So the power of 216?
Nope. It's too much. All right, here, look at this. Let's make it easier. X squared to the power of 3. What is that? X squared to the power of 3.
X to the power of 6.
Yeah, you multiply them, right? You multiply the exponents.
Oh,
So it's gonna be B18, but it's also not gonna be 6 here. What is it actually gonna be? We're doing -2 cubed. We're not doing -2 times 3. It'll be -8. Yeah,
mhm.
and that's the right answer. It says it's a 2-step answer, as long as you know your rules. You never have to do something like this. You know, it's not gonna be like 2 to the power of 4. No, you simply multiply them. Okay. The only time it's gonna be 2 to the power of 4 is if you have something like this, number and a number. Double exponents, you just multiply them. Let's look at R. Open that first bracket for me. This bracket. Now remember, this squared applies to the x. It also applies to -3.
9x to the power of 4.
Yeah, good. Open the second bracket.
8x to the power of -6.
Yes. What's the next step? You multiply the number with the number and the letter with the letter, okay? 9 times 8 is what, 72? What about the x's?
You add the exponents.
Right, so what do you get?
X to the power of -2.
Right, how do we make it positive?
You put it under a 1.
Yeah, or you put it under, we already have a number there, so we're just gonna put it over the number. That'll
Okay.
be the final answer there. Cool.
Mhm.
It's gonna get more difficult, but it's okay. We're ready. Most of them are just two, 3 steps maybe. Okay, let's do this one by one. The 7 is there. We can't touch that, right? There's no other 7s. We'll just leave it there. Now think about it. Do you bring x minus 4 up, or do you bring that x down? We're looking to get positive exponents.
You bring x minus 4 up.
Yeah, what do you get? How many x's on top then?
4.
There's already a 1, right, on the top?
Oh, 5.
5. How many y's? Bring the y -2 up.
3.
Yeah. Yeah, there we go. And that's the answer. Easy as that. Look at this one. 7 over 4. Can't reduce them. One of them is a prime number. Y6, do we bring it up? Or do we bring do you bring this down or 5 up?
5 up.
How many do you get?
11.
Nope. You bring it up, it's gonna become 6 minus 5. You're left with 1.
Oh.
Here it was a double negative. That's what happened. You did x minus -4. That's why it became 5. Okay, 1 minus -4. And then z, there's only one z, so we just leave it as it is. And there you go. It's again a 1-step answer there.
Okay.
This one may not be a 1-step answer, but we'll figure it out. So let's focus one thing at a time. So there's no squared or cubed in the brackets, okay? So we're gonna group the numbers with the numbers. 2 and 4, multiply them, you get an 8, yeah? Now look at x's. We have 3 x's. We have x3, we have x4, and we have x, and we're multiplying all of them. How many do we have left if we simplify that?
X to the power of 4.
No. So we're doing x3 times x -4 times x. Okay, we're just multiplying all of them, right? That means you add all the numbers, all the exponents.
So x to the power of -1.
Again, be careful. If there's an x with no number, that means it has power 1, okay? It's going to be 8x0, right? You see that? 3 minus 4 plus 1. -1 plus 1, that's a 0. So it's x power 0, which is a 1.
Okay.
How many y's?
2.
Yeah, that's right. And there we go. That's the answer. And x power 0 is a 1. So it'll just be 8y squared. Final answer.
Okay.
Here, let's try simplifying this. So there's a bunch of things inside the bracket. So if you can clean up the inside first, that's always going to be helpful. So we're going to work our way from inside to outside. What do we get on the inside if we simplify them?
Do you multiply the numbers?
Yeah, the numbers you would multiply, yeah.
12x to the power of 3.
Right. Now, if you open this bracket, you're going to get 12 cubed, not 36, okay? 12 cubed, how many x's?
6.
No.
I mean 9.
9, yes. And there we go. That's the answer. Whatever this number is, it's going to be a big number. Which one looks dicey? Let's do this one. K, we're doing K. Again, if you can clean up inside the bracket first, it'll help you. So let's look at this. Again, there's a 3 on the outside, okay? Do we bring this down or do we bring the other one up? So this is a question you have to ask yourself.
Do you bring the -3 up?
Yeah, so how many A's do you get on the top?
6.
Right, how about the B? How many B's?
4.
On the bottom, is that what you meant? There we go, open this bracket.
You just multiply, right?
Yeah.
A to the power of 18, and
Yeah.
then 6 to the power of 12.
Right, that was a B, but yeah, that's right.
Oh.
Here, this one's a little bit trickier because we can't clean up the insides, you see? There is nothing to clean up. So what do we do in these cases? We're just going to distribute the powers, okay? This 5 applies to both x and y, yeah? So you get x5, y10, like that. What do you get in the other one if you open the bracket?
X to the power of 6, and y to the power of 9.
Yeah.
And then z to the power of 6.
Yes. Now there's only one z6 and it's in the bottom, so we leave it at the bottom. We have x5 here times x6. How many x's?
11.
Yeah. y9 on top, y10 on bottom. What do we do?
Subtract.
Yeah. So how many y's on the bottom?
1.
1, and you're done. Okay. Which one looks interesting? This one, let's try. Okay, tell me, what's the next step?
You bring the -6 up.
Yeah, so how many is left?
9.
Right, what about the y?
You bring the -5 down.
13, right?
Mm-hmm.
And what's 16 over 4?
4.
Yeah, and you're done.
Okay.
Easy as that. Okay, this one, I guess we could simplify the inside. Let's simplify the inside part.
You bring the -3 up.
What you get?
1.
So -1 plus 3 is going to be 2.
Okay.
What about the y?
You bring the -2 up.
So how many do you get?
3.
Right. Now let's open this bracket. Actually, there's everything is over 1, right?
Mm-hmm.
Because there's nothing left. Let's use the advanced technique to save time. What we're gonna do, it's not really an advanced, this is a trick, it's just an exponent trick. If you get something like this, if I wanna make, yeah, you flip it upside down, the exponent automatically becomes positive, right? Like that.
Mm-hmm.
I can also do this to start off with in the very first step, but it's easier when it's cleaned up. And now the cube applies to everything. So tell me, what's the final answer?
Um, 8x to the power of 6.
Yeah,
And then y to the power of 9.
right. All right, so now if you remember these things, it says express in exponential form. That means something to the power of something, okay? It's again a one-step answer here. Let me show you some examples. Square root of 2 is 2 to the power of a half. Square root of 2 cubed is 2 to the power 3 over 2. Now, where's the 2 in the bottom coming from? That comes from the square root, okay? See that?
Mm-hmm.
Let's say you have fifth power of 3. What is that? If you want to write that in exponential form. It'll be 3 to the power of 3 over 5. Cool? See that this comes in the denominator, all right? So tell me, fifth root of x6. No, it's the same thing, right? It's the same thing. It's going to be 6 over 5, one step.
Okay.
What about b?
3 over 8.
Right. And you're done, okay?
Okay.
Let's get a little bit more trickier here, but that shouldn't change anything. Same rule. Look at this one. C, it's gonna be 1 over x to the power something. What's the exponent?
5 over 2.
Yeah, good. What about D?
X to the power of 4 over 3.
Right. Now E is complicated. Well, it's not really complicated. You just have to kind of think outside the box. Leave the fourth root on the outside, okay? What do we get first if we clean that bit?
Oh, 1/3.
Yeah, x to the power of 1/3. Now notice the 4 is gonna go in the denominator as well, okay? So it's gonna become x to the power of 1 over what? That 4 is gonna go right there with the 3. It'll be 1/12. Okay? The root thingamajig always goes in the denominator. So if there's already a denominator, just multiply them together. Cool?
Okay.
Look at this. Square root of 1. Okay, we're just gonna forget about the square root of this bit. Let's clean up that. What do you get in the bottom?
1/5.
Right, 1/5. Now remember, that's a square root. What'll be the last step here, final step?
You get 1/10.
Yeah, that's absolutely right. And square root of 1 is a 1, okay? Just remember, square root of 1 or fifth root of 1, a negative 20th root of 1, they're all 1s. 1 to the power of anything is also a 1. So square root of 1 is a 1, and then you get x to the power of 1/10 on the bottom final answer.
Okay.
Now what if we flippity flop? Now they want us to write in radical form. Okay? They want us to write in radical form. So basically it's gonna be x to the power of, actually no they don't. They just want to simplify this. Well, in that case it's very simple though. But let's say we want to write this in this form. X to the power of something here and something over here. Okay? How do we do this? First simplify it, right? You're multiplying two different x's. Let's add the exponent. What's 5/2 plus 3? You can do this on your calculator. We don't have to worry about showing the fraction work, whatever.
5.5.
Yeah, which is 11/2. Okay. There's a button on your calculator or whatever that's going to convert it into fractions. So if you want to write this in that form, what do we get? In this form.
X to the power of 11.
Yeah, there we go. Okay. Easy as that. Now here's a question for B. Do we bring the 6th, 7th down or do we bring the 4 up?
You bring the 4 up.
No, you don't, because 6, 7 is less than 1, right? 6/7 is gonna be less than 1. So if you bring this up, you would get a negative exponent. Okay? You should bring the 6, 7th down. So it's gonna be 1/x to the 4 minus 6/7, like that.
Okay.
And that's the same thing as x to the power of 28 minus 6/7 when you take the common denominators. So you get 1/x 22/7. What's the final answer? I'm gonna write this in radical form.
X to the power of 22. The root of 7.
Yeah, good, perfect. There we go. 7th root of x power 22. Alrighty? Yeah, so today was better than last time for sure. Because you're getting used to this, right? It's just notation. And if you notice, most of the answers were like 2 or 3 steps. And the math is simply like very simple as well, like plus minus, and worst case you got to do something power something. So the arithmetic is pretty simple. Just the rules. All right, let's call it a day there.
Okay, thank you.
See you next time.